Hey everyone, welcome back, and today let's solve Leetcode problem 3000 titled Maximum Area of Longest Diagonal Rectangle. So pretty straightforward problem statement here. Just to quickly summarize, we're given a 2D zero index integer array dimensions, and for each index, if you will, in the dimensions, we have a pair, which is going to basically just be the width and the height, or the width and the length of the rectangle. We want to return the area of the rectangle that has the longest diagonal, and if there are multiple rectangles with that longest diagonal, we want to return the one that has the maximum area. So really there's two key variables that we keep track of as we iterate through the dimensions input array. That would be the maximum area that we find so far and the maximum diagonal length. Right, so in example 1, we have our dimensions to be a square, or rather rectangle of 9 comma 3. The width and height are these corresponding values, and the same applies for 8 comma 6. In this case, the reason why 48 is our answer is because that is the area of the rectangle that has the highest, or rather longest diagonal length, or the maximum area across all the rectangles that have that highest or longest diagonal length. In this case, the longest diagonal length that it has would actually be 10. Right? And the way we actually compute diagonal length is basically just by multiplying the two sides, summing them together, and taking the square root of that value. For 9 and 3, that would be 9 times 9 plus 3 times 3, and we take the square root of that, which would be approximately 9.487. Applying the same operation to the square root of 8 times 8 plus 6 times 6, that would be the square root of 100, or 10. In this case, 10 is greater than 9.487, meaning that 8 comma 6 would be a rectangle, or rather represent a rectangle that has dimensions, that has a diagonal that's longer than the 9 comma 3 index, and so that's why I would return the area of this longer dimension, or this longer index, which would have an area of 8 times 6, or width times height, which would be 48. Applying the same logic to example 2 here, we see that 3 comma 4 and 4 comma 3 both actually do have the same exact area, and the length of the diagonal is also the same. And so it really doesn't matter which one we choose here. They're both going to have that maximum area and that same exact diagonal length, both of 12. And that's why that is our final output. So for the constraints here, we see that the length of our array dimensions, aka the number of actual rectangles that we're going to have, is always going to be between 1 and 100. We're only going to have at most 100 elements. And any value in the dimensions index, or rather any index in the dimension input array, is guaranteed to only be 2. It's guaranteed to always be a valid rectangle with only a height and width input, and that those values are also going to be between 1 and 100. And when I say those values, I really mean the height and the width, kind of just confirming and guaranteeing what the problem statement said, and kind of just confirming that we always will have valid inputs. Which brings us to how we really solve this problem the most efficiently. And the real way to really solve this problem, look at it, is it really just is a straightforward Leetcode easy. It is just a direct simulation or iteration problem of our input, where we really just iterate over the matrix and keep track of the maximum area and maximum longest diagonal length, and just return that maximum value accordingly, while checking for those different cases when we actually encounter a potential new max as we iterate through each index or each pair of dimensions in the input array dimensions. Right? So let's go ahead and get started, right? So the first thing that we usually do in such type of problems when we're trying to maximize something and keep track of a maximum value or maximum values as we iterate across an input, we first have to actually initialize those maximum values that we're trying to maximize and keep track of. In this case, there are two different factors, or two different variables, right? There would actually be the longest diagonal length and the maximum area. And so I'm just going to call it best D2. And I'm going to initialize this just to be -1, or really any negative value you want. Effectively, this is going to be our longest squared diagonal, and this is what we calculate per, or rather for each iteration, for each index as we iterate through the input array dimensions while trying to maximize the value. The next thing that we're going to look at is our actual best area, right? And you guessed it, I'll call it best area. This is the area that we're trying to maximize. I'll just set this equal to 0, but this is effectively what we have to actually return as the highest area for the rectangle with the maximum area that also does have the longest diagonal length. And the first thing that we check is the longest diagonal length. If multiple have the longest diagonal, only then do we actually check for which one has the maximum area. So this is the first thing that we check, and then we move on to checking for the best area as we iterate through each dimension or each pair of dimensions for each rectangle in the input array dimensions. Now that we've actually initialized the two variables that we need to keep track of and maximize, we can begin iterating through our input. And the way I'm going to do this is actually keep track of both a length and a width to actually easily calculate our square diagonal value and our area for each rectangle that we iterate over in the input array matrix, or rather in the input array dimensions. And so I'm going to say for every L and W in the dimensions input array. Now in Python, I'm really just using these two iterators because every single index in the input array dimensions is going to have a length of 2, meaning I need exactly 2 iterators to go through each value in each index or each sublist of the entire dimensions main list, right? And for every value or length and width or every rectangle pair of dimensions in each index of this dimensions array, let's first calculate its square diagonal. And we discussed this briefly in the examples as well. D2, basically the current square diagonal value for the current rectangle, if you will, is going to be L times L plus W times W. If I can find my W, right? That's going to be our value for D2, or our squared diagonal. From here, we're then gonna get the area. The area, you may have guessed it, is just L times W. Very straightforward. Nothing too fancy about that. It's just length times width, calculating the both squared diagonal and area of the current rectangle. And here is where we actually have to check for the conditional if the current rectangle is the bigger or the largest value that we've seen so far. It has the largest area or the largest diagonal length. And the way we can actually check that quite cleverly and in one sentence or in one line here is first, if D2, the current square diagonal length, if that's greater than the best D2 or the highest D2 that we've seen so far across any other rectangles, or its area is bigger across any other rectangles that we've seen with the same highest diagonal length, and the way we check that is or D2 is equal to best D2, meaning it's the same or highest diagonal length as what we've seen before, however this one has a higher area. So and area is greater than the best area that we've seen so far. If either one of these conditions hold to be true, the one in the parentheses or this value itself, that means that this is our new best pair or our new best rectangle, and so we have to update our best D2 and best area variables accordingly. So best D2 would be the new D2 that we just calculated as the highest D2 for this iteration, which would just be D2, and our best area would be updated to the new area, which would be the new best area of the current rectangle, which would just be area. And effectively, once we do these operations and conditionals for every rectangle or for every pair of dimensions in the input array dimensions, we'd simply return what the problem statement asks us, which would be the maximized best area variable. And so unless I made in syntax errors here, there should be accepted and there should be a valid solution. So let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be, right? So in a high level, how are we really solving this problem? Again, very standard Leetcode easy. Just keeping track of two variables here, trying to maximize them as we go for every single value or index or rectangle in the input array matrix, and we're just rather in the input array dimensions, and just trying to maximize those values as we go, as we calculate them for every rectangle in the input. Right, so that brings us to the complexities of this solution here. For the runtime complexity here, quite straightforward. It is just linear, big O of n would be the number of rectangles or indices or the length of our input array dimensions. And for our memory or space complexity, believe it or not, it's actually going to be constant or big O of 1. The reason why is because we're not actually using any auxiliary memory or any extra data structures that scale with our input. We're just using a few extra integers like best area and best D2, which are just integers that take up constant space, and so this is a big O of 1 or constant memory or space complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel, and without further ado, I will see you guys in the next video. Bye bye.